Okay, so here we are on page 205 of our math books, and it is the second page of the review pages for this unit, for Unit 5. So I'm on page 205. Number 9 says, find the perimeter and area of the rectangle. So you'll probably have quite a few of these on your test. Just knowing the difference between perimeter and area, we've gone over this quite a bit. Remember that perimeter is adding up all the sides. So it's just a length around the entire figure. Remember that the most common mistake for this would be some students just do 12 plus 9 because they remember that they're supposed to add up all the numbers, and those are the only two numbers that they see. But we have to remember that there is a 12 and there is a 9, right? So there's always going to be four numbers that you're adding up if you're finding the perimeter of a quadrilateral. 12 plus 9 plus 12 plus 9. There are fancier ways to do this. I've noticed some of you vlogging about them where you can put this into a really cool equation that looks a little bit like this, right? Because you have two 9s and two 12s. But for most of us, that might be a little bit too confusing right now. Just keep it basic. Just remember that perimeter is adding up four sides. So if we do take 12 plus 9 plus 12 plus 9, we get to 42 centimeters. Again, noticing that the unit is just centimeters because it's just a length. So it's just a distance from one spot to another. When we get into area, remember that it is the length times the width. So here you're only using two numbers and you're multiplying them. 12 times 9, which equals 108. Noting that now, because we're talking about area, we have to label it as square centimeters. Because remember, area is the space inside a shape. So you're literally counting how many squares. That's why we say square centimeters. And the abbreviation for that would be centimeters squared with that little 2. And we can remember what that 2 stands for because it's a two-dimensional shape. It has length and width, not just length like the perimeter does. Okay, number 10, draw a line to match equivalent measurements. So on this one, you're just going to be able to need to identify how many of these would equal which one of these down here. Some of them are kind of obvious. You know that if you're working with inches, that's a unit of length. So you can look down here and see which one of these is a unit of length. There's only one, feet. So it's probably going to be feet. And then you can double check yourself. How many inches are in 1 foot? 12. So 12 is my conversion number. And then I know that 4 times 12 is 48. Okay, what about 9 tons? Which one would go with that down here? I remember that tons are really, really big. I remember that there are 2,000 pounds in 1 ton. Now, if you don't remember that, you're allowed to look that kind of thing up. You're allowed to keep a chart of that kind of information. So looking at down below, I remember that I just said the word pounds. That's the one that makes the most sense. Ounces are small, so I know that that's definitely not going to equal 9 tons. My conversion number here is 2 because 2,000, oh, sorry, it's 2,000, not 2. 9 times 2,000 equals 18,000 pounds. Moving along to the 24 cups, I only have 2 choices left. I wonder which would make most sense, 288 ounces or 192 fluid ounces. So this is where we have to remember which type of ounces we're using. If we're looking at cups and quarts and gallons, thinking about the gallon man, all of that is fluid capacity. So when you're thinking about that, it really means how much fluid or how much liquid can something hold. Therefore, our 24 cups is probably going to be down here to the fluid ounces. And then you have to remember how many fluid ounces are in 1 cup. If you forget, the best thing to do is to go back in your book or look it up online. There's nothing wrong with that right now. What we're practicing is the conversion. We're not really needing to memorize every single conversion. Okay, so looking back here, I can see that here is my liquid volume. Liquid volume is another way of thinking about fluid capacity. And looking around, I see, aha, 8 fluid ounces equals 1 cup. So I go back to my original page and I think about 24 times 8. And if I do 24 times 8, I will get 192. Last but not least, I could just draw the line here because I've got it, or I could make sure. I could really practice my skills. So 18 pounds to how many ounces? So remember, this is a different number because ounces in 1 pound are going to be 16, whereas fluid ounces in 1 cup are 8. Don't be afraid to look that up every time you need it because you do not want to make that mistake. So 18 times 16 is going to get me to 288. Number 11, during a speech, a motivational speaker says, there are 1,440 seconds in each day. How will you spend yours? Do you agree or disagree with the speaker? Explain your reasoning using words and numbers. So you're going to have to decide here, are there really 1,440 seconds in each day? How could we figure that out? How could we figure out how many seconds are in a day? Well, I know that one day has 24 hours in it. So I'm going to say 24 hours. And then I know that I need to figure out the next thing, which would be how many minutes are in hours. So I would do 24 times 60. Off to the side, I'm going to write that out so that I have it, my work a little bit separated from my equation. Okay, so 24 times 60 is 1,440. Oh, that number looks familiar. I have to make sure that I label this. So this is this is hours, this is minutes. So I've now converted to get to minutes. But what did the motivational speaker ask for? Seconds, that's correct. So I would need to take this number and multiply it by what to get seconds? 60 again, because remember there are 60 seconds in 1 minute. And when you multiply that, obviously you're going to get a bigger number than this because you're multiplying. A good answer to this in a complete sentence might be something like, I do not agree with the speaker because there are 1,440 minutes in each day. Therefore, there cannot be the same amount of seconds in each day. You could even go further and say you would have to multiply that number by 60 to get the correct number of seconds in each day. Okay, number 12. A bear cub weighs 64 ounces in March. After 3 months, it weighs 31 pounds. So I'm going to make some rectangles here, fourth graders. What do you think I'm going to need to convert? Do you see some units here? I see ounces and I see pounds. Go ahead and circle my numbers. Okay, so this is a classic example of having a story problem or a word problem where the first thing I want to do is just do the math. I don't want to worry about the conversions quite yet. So I've got 64 ounces. After 3 months, it weighs 31 pounds. How many pounds did the cub weigh in March? Actually, never mind. We're going to go to that 64 right away and just convert it into pounds. I was thinking this was a different one. So let's think about this for just a minute. How many ounces are in 1 pound? 16. Now, that means that 16 is going to be my conversion number. Do I want a bigger number or a smaller number if I'm going from ounces to pounds? I actually want a smaller number, right? Because there's going to be less pounds in something that weighs the same thing than ounces in that thing that it weighs the same. So fourth graders, look at this. We have to go 64 divided by 16. This one looks a little bit harder because we see that we're dividing by a number that is a 2-digit number and we're not necessarily used to that. But we're not going to let it stop us because our good old guess and test trick totally works here. So when I set it up, I'm thinking, 16 goes into 64 how many times? Obviously, I do not have my 16s memorized. Maybe you do, but most of us stop at 12s. So because of that, I'm going to need to do a little testing. Now, I can be smart about my testing. I know that 16 times 2 is 32. I happen to have that memorized, so I know it's going to be more than 2. And then if I keep thinking about the number 32, I probably can notice something about 64. I wonder if 64 is 32 doubled. So you see how you can kind of think about it that way. But again, making sure that we show our work. 16 times, I'm going to try 4 because that was my mental math giving me a little push there. 6 times 4 equals 24. 4 times 1 equals 4. Add the 2, 64. So 16 times 4 equals 64. So how many pounds did the cub weigh in March? 4 pounds. This is a really great place to pause and see, does your answer make sense? Because this is a hard problem with the math. We want to make sure that it actually makes sense. Would it make sense for a bear cub to weigh 4 pounds and then 3 months later to grow to 31 pounds? Actually, probably, right? Bears are really big. They probably grow at about that rate. I know that at least my answer is less than 31, so that's good news. If it was more than 31, then it wouldn't make sense at all, right? Because the baby would never weigh more than it did 3 months later. At least let's hope not. That'd be an unhealthy bear cub. Part B now has us going a little bit more into detail. Use words and numbers to show that the bear cub gained more than 25 pounds after 3 months. Oh, this might not be too tricky. We know it started at 4 and it got to 31. How much did it gain? You could also say to yourself, how much more does the bear weigh now? If you're thinking about how much more, then you've given yourself that clue word, and that clue word usually means to subtract. So we're taking 31 minus 4. Okay, so if you take 31 minus 4, you're going to get 27. Ooh, did it gain more than 25 pounds? Yeah, it gained 27 pounds. So you would then write in a complete sentence, I know that it gained more than 25 pounds because 31 minus 4 equals 27, and 27 pounds is the amount that it gained. Jill asked her classmates how many hours of sleep they got last night. She displayed the data in the line plot shown. How many classmates did Jill ask about the time spent sleeping? So looking at this line plot, we remember that each thing that is done is one dot or X. So if you count all those up, you would get 23. That one wasn't too tricky. Which mass is equivalent to 55 decagrams? All right, here we go, King Henry. Deca. Okay, so I know I'm in deca. Let's see. 55 kilograms, would that be equivalent to 55 decagrams? Wait, that doesn't make any sense because it's the exact same number. So that couldn't be right. I'm not going to do that one. Boink. What about 550 grams? Okay, let's check it out. So that would be one hop, right? Because it's 1 0 added. There's deca, there's grams. Adding 1 0 going this way, because remember, multiply or add a 0 when you move to the right. Yes, that one is correct, 550 grams. What about this one? 5,500 centigrams. Moving from deca to centa, let's see how many hops. 1, 2, 3. Okay, so 3 zeros after the 55. That only has 2 zeros after the 55. 5 hectograms, 5 hectograms. Okay, so there's hecto. And then we're going from hecto to deca. Okay, so it is only one hop, but that would mean I'd need 1 0, or to take away 1 0. This actually could not equal it because we would need to move the decimal over. Nope, that one's not going to work. Okay, what about 550,000 milligrams? So starting on deca, we have to decide how many hops we're going over, and that'll be how many zeros we add to the 5. 1, 2, 3, 4. Okay, so 4 zeros after the 55. Let's count these. 1, 2, 3, 4. Ah-ha-ha! Whoa, that's a lot of milligrams. Remember, milligrams are super, super tiny. Last one, 55,000 decigrams. So remember, knowing the difference between deci and deca, this is a great way for us to practice it. We're looking at how many decas. So we know that we're going to go over 2 hops, 1, 2. How many zeros is that? Obviously, it's 2 zeros. But when we look at our number here, there are 3 zeros in our number. So we only have 2 correct answers on that particular one. All right, guys, so I'll make sure that your assignment today only has the problems from this section. Really make sure that you watch this video again if you need to, or as you're doing the problems online, because some of these can be pretty tricky. Have fun.